Okay, so this is still topic 6.3. We're going to go ahead and talk about notation. The first 3 problems are fairly straightforward. And the last one, we're going to do some calculating. All right, check. Snow starts falling at 6 a.m. The rate that snow is falling overnight is represented by the equation S prime of t, where S prime of t is measured in inches per hour, therefore it's a rate, and t represents the hours since midnight. Write an integral expression that gives the total amount of snow that falls during the first 3 hours of snowfall. So at 3 hours, snow started falling at 6 a.m., but t equals 0 is midnight. We want an integral expression. Integral expression. S prime of t is our function. Make sure your integral is really a tall, skinny S if you're thinking about how to draw that shape, but make sure it looks different than an S. Okay? And think about it as a sum, so maybe that's why it's S-shaped. We got dt down here because that's going to be our variable. That part's easy. Now, what are my limits of integration? So first 3 hours, we know they're 3 hours apart. 0 is midnight. It would really be cool if I could spell. So 0 is midnight. Excuse me. So snow starts falling at 6. So snow starts falling at t equals 6. And the first 3 hours of snowfall will be from t equals 6 to t equals 9. So 6 to 9. That's it. That's all I want. Hardest part, figuring out the endpoints. Okay. Next, the function c prime of t gives the rate in bars per minute at which chocolate bars are being removed from a shelf at the grocery store. I'm going to put this over here. At the grocery store. Where t is measured in minutes? Using correct units, interpret the meaning of the following expression in context of the problem. Okay, so we're going from 0 to 9 minutes. So in the first 9 minutes, so that's just the 0 to 9 part, in the first 9 minutes. So think about going back to this one, in the first 3 hours, but 0 was midnight, so it was from 6 to 9, so for the first 3 hours of snowfall. That's a little bit weird, but that's the idea. And gives the rate in bars per minute in which chocolate bars are being sold. So c prime of t is bars per minute, so the number of bars sold each minute. When we integrate c prime, we're going to get c. And so in the first 9 minutes, equal to 46, so 46 chocolate bars were removed. From the shelf. So, again, my units will just be bars because I'm integrating bars per minute times minutes. The delta t is minutes. And so bars per minute times minutes, and that's why minutes are gone. Okay, no big deal. All right, harder. Paul is using rectangles to find the area under a curve on the interval from -2 to 7. Use interval notation to express the following limits. We have this limit. So remember, this is supposed to be f of I, x sub I, which means that f of x must equal 3x squared minus 5x, because I is in each of those places. Okay? So my integral is going to go from -2 to 7, because that's my interval. You can't see that in here. It's nowhere to be seen. So I have to know that. of f of x, and I'm going to go ahead and write the equation. Put it in parentheses, dx. That's all there is to it. Recognize what the equation is. Find your limits, endpoints, and you're all set. Again, endpoints aren't to be found here. You have to know that from somewhere else. All right, you ready for the hard part? All right. Because all of this isn't hard, it's just an understanding questions. We'll see. I mean, it isn't easy, but it's just understanding versus the actual calculations. Okay. The volume of a spherical hot air balloon expands as the air inside the balloon is heated. Select values of r prime of t, the rate of change of the radius in feet per minute, is given in the table below. Use a right Riemann sum with 5 subintervals. Notice it does not say equal, but it says 5 subintervals as indicated by the table to approximate the interval. So 1, 2, 3, 4, 5. Okay. Then I need to figure out how wide each one is. And I have already have the equation. Okay. So it's right, so I'm using these numbers. So this is the one being left out because it's right. So this one goes with that, this goes with that. Okay. So this one is 2 wide times the value of the function. This one is 3 wide times the value of the function. This one is 2 wide times the value of the function. This one is from 11 to 7, 4 wide times the value of the function. The last one is 1 wide times the value of the function. I should really go like this so that my decimal and my number doesn't throw me off. So that's 8 plus 6 plus 2.4 plus 22.4, 24, 4 times 6, put the decimal in, plus 0.5, which is equal to 4.8, 10.8, 18, 19.3. Using correct units to interpret our answer. So during the first 12 minutes, I know it's minutes because it says feet per minute up here. I know it's the first 12 because it goes from 0 to 12, first 12 minutes. Okay, the radius of the hot air balloon grew by 19.3 units, feet. Okay. And the units are these two. I'm grading both of those. That's it. So the circuit that I assigned is a lot of this, not very much of this, although I can find you one of those if you want to practice it. And okay, and that's it. All right, we'll see you guys soon. Have a great day.